Hi, I am Artem Chmatko and this is Using Gremlin with DSE GraphFrames. Gremlin is a preferred language when it comes to defining traversals in DataStax Enterprise Graph. This is also true for DSE GraphFrames. Here we describe a general strategy of using Gremlin API with DSE GraphFrames. The following code is executable, for example, in Spark shell. First, we create a DSE GraphFrame for a particular graph that exists in DSE Graph. We call method DSE Graph for killer video on the Spark session object. Second, we begin our traversal with methods v or e, just like a regular Gremlin traversal. Next, we use Gremlin steps such as in, out, both, has, and so forth. Finally, we use a method that can trigger computation in Spark, such as DataFrames show in this example. This is a list of Gremlin steps supported by DSE GraphFrames. I assume that you have the required prerequisites and already familiar with Gremlin, so I will not go through individual steps. As you may recognize, types of traversals that we can define with these steps include simple, projecting, statistical, and ordering. Of course, there are a number of other Gremlin steps that may not be supported yet. You should check the documentation for the most current list. If a certain Gremlin step is required for your traversal and is not currently supported by DSE GraphFrames, there are always other Spark APIs such as Spark GraphFrames and DataFrames that can complement your traversal. All Gremlin predicates are supported by DSE GraphFrames. To use a predicate, you have to qualify it with P. There are also 4 tokens that can be used to refer to a label, ID, map key, and map value. For example, if you need to group count by label and order by key, you will need to use those. They are qualified with T. Let's look at some examples. These 2 traversals compute simple statistical information about our killer video graph. We count how many vertices we have in the graph, as well as find vertex distribution by vertex label. Because we use DSE GraphFrame API, all computation is done by Spark. In this example, we are dropping all nose edges in the graph and output edge distribution by label. As you can see, there are composer, director, belongs to, actor, cinematographer, rated, and screenwriter edges. There are no longer any nose edges. Drop can also be used to drop vertices and properties. And this is one way to do bulk dropping with Gremlin API of DSE GraphFrames. There is another way that uses DSE GraphFrame API directly, and it also supports bulk insertions and updates. We will talk about bulk operations in more detail in a separate presentation. This is a simple traversal that finds Robert De Niro's movies from 1970s. We start with the vertex with label person and name Robert De Niro, traverse all incoming actor edges, and get to the movie vertices. We then verify that the year property is greater than or equal to 1970 and less than 1980. We get to the title and year values of such movies and output them using DataFrames methods show. The result contains 3 fine movies. Our next example of a Gremlin traversal combines steps of both simple traversals and statistical traversals. We find the person vertex for Robert De Niro, hop to his movies, and get to rated edges so that we can retrieve movie ratings. We then compute the rating distribution for all of Robert De Niro's movies. Notice that the results are not ordered. It would be nice to improve this traversal to output the result in the ascending ratings order. Even so, Gremlin traversal step order is supported by DSE GraphFrames, the local scope to order a map is not. For now, we will have to use another API for ordering. In many cases, the API that readily complements Gremlin when using DSE GraphFrames is DataFrame API. We have already seen DataFrames show method that triggers execution and displays the results as a table. Other methods can be used to implement operations that are not available in Gremlin API and even combine graph and non-graph data in a single query. As you will experience soon, Gremlin and DataFrames is a very powerful combination. So here we find rating distributions for Robert De Niro's movies and order the results by rating. As before, we find the person vertex for Robert De Niro, traverse incoming actor edges to his movies, and get to rating edges so that we can retrieve movie ratings. We then compute the rating distribution for all Robert De Niro's movies. Finally, we order the resulting data frame by its rating column and output the result. Notice the df method that is used to convert a DSE graph traversal object to a data frame object. We can omit it in Scholar and Spark Shell as the conversion happens implicitly. However, it can also be convenient to keep for better readability and easier distinction between Gremlin and DataFrame APIs. Now let's go a bit further. Let's save the result of our analysis of Robert De Niro's movie ratings into a Cassandra table. We should assume that we already have Cassandra keyspace killer_video and empty table De Niro ratings with columns rating and count. The traversal itself should look familiar. There is a Gremlin part where we compute the Gremlin distribution and the data frame part which uses Spark Cassandra connector to save the results to Cassandra. If the saving to Cassandra code looks new to you, consider taking our course on DataStax Enterprise Analytics with Apache Spark on DataStax Academy to learn more. Lastly, we use Spark SQL to retrieve data back from Cassandra table to see that we indeed achieved our goal, and it worked. And finally, our most complex example, where we find and compare rating distributions for Al Pacino and Robert De Niro by retrieving and combining data from both Graph and Cassandra. That should be interesting. We get Al Pacino rating distribution from the Graph and Robert De Niro's rating distribution from the table in Cassandra we populated in the previous example. We then take the two resulting data frames or tables and perform a full outer join on the rating column. The full outer join is required to preserve any rows from both tables that cannot satisfy the join condition. We order the resulting table by rating and show the result. You should be able to recognize that this traversal uses Gremlin, DSE GraphFrames, DataFrames, Spark Cassandra connector, and Spark SQL. Now that's what I call powerful, and it is time for you to embrace the power of DSE GraphFrames Gremlin side.